Hello, hello. Nice to meet you on our Go Spring Meetup from Go Community Leaf. Finally, we're back to you guys. Whole that year was so tricky for all of us. Remote work, working from home. Finally, some of us came back to office, and that amazing spring allow us to prepare for you a couple of interesting topics. Today we have two speakers, uh, Yurii and Bogdan from our community, with really amazing talks. Let me explain to you how it will go today. Feel free to chat with us using YouTube chat. We will show your amazing comments in our stream. Also, someone who wants to participate in our stream, please just write a message in chat if you have question to our speaker or anything. We will send you a link directly in private messages, and we will include you in our stream. Please let me introduce our first speaker, Yurii. Hello, Yurii. Could you please push button?
Yes, hello.
So I know you prepare a really amazing topic for us about Azure CosmosDB. To be honest, I don't have experience with such database. What about the talk?
Yeah, I'm working with the CosmosDB for 1 year, and I gained some experience with that that I want to share with you and people who join the meetup. And I think that might be interesting for people who would like to get some knowledge about new databases that's coming on the market.
Awesome. One thing which I totally forgot. After Yuri's talk, we will have some time for questions and answers session. Yeah, be ready for that. Listen carefully. I wish you lucky, Yuri, and let's start.
Thank you. I will start my presentation. Wait a second. Cool. I think we can start. So my name is Yurii Shnitsar, and I'm software engineer at EPAM. And as I said, that I have some experience with CosmosDB. I worked with Cosmos for a year, and I will share some knowledge with you what I've gained for this year. At first, I would like to start with the explanation what really Azure Cosmos is. And at first, Azure Cosmos is a fully managed NoSQL database with 3.9 after .% availability and automatic and instant scalability. Also, Cosmos supports different open source APIs like MongoDB, Cassandra, or eSQL. Also, it gives us turnkey data replication and multi-region writes. If you want, you can click on the real-time data. You can enable real-time data analytics with Azure SynPace. Okay, I will tell you a bit about my experience. And at some point at the work, we decided to support multi-cloud, and our last point is going to be portable stack. Everything should be open source, and as a database solution, we decided to have MongoDB. As the next step as one of the steps of the migration, we decided to move to the Azure, and since we know that CosmosDB supports Mongo API, this next step of the migration is going to be very smoothly. But this way takes a bit longer time than we expected. And it really looks like this: GCP, and then CosmosDB, CosmosDB, and then 3 times again and again CosmosDB. There is many tweaks and many things that we have to understand when we are using CosmosDB. That's like a things with the cosmonaut. I found this picture and thought, what is in common between the cosmonaut and the people who use Cosmos? Really, there is one thing that is common. The cosmonaut and people who use Cosmos must take a lot of trainings and understand a lot of things to start doing this job. I think that we can start from the request units, and request units is some abstraction around usual memory, CPU, IOPS. Azure thinks that we don't need to think about this. We have one simple request unit, and we can go with request units. What the reflect number of request units, and where we use this request units? When you do read, insert, upsert, or delete, you always use the insert. You always use the request units, and if you read, yeah, you can. It can take different number of request units, and let's take a look of what we can improve or take when we are talking about the cost of the operation. Yes, item size reflect the every operation. Also, item indexing reflect the operation, item property count, indexed properties, data consistency, query patterns. All of this reflect the number of request units you are going to use. Take care of this because it's very important when you use Cosmos. When you start working with the database, you have to create your database and provision number of request units you need. And how you can do this? You can do it through in the different ways, but I will show you the simplest one. We will go with the UI, and you click on the collection, create, and then you create a database and collection. You can click if you want to shard throughput across all collection, but you can create separate throughput for separate collection. It depends on what you want. If you have some collection very loaded and nobody is using other, you can simply set bigger throughput for one collection that's with high load, and don't take care about the rest of the collection. Also, CosmosDB out of the box support sharding, and you have to set the shard key. We will talk about this a bit later, but remember about this. Also, what the important part of this slide is how you can provision your collection or your database. You can set the throughput into two modes. It's auto scale and manual. And what's the difference? When you set to the manual, Cosmos will provision will have the same number of request units for all the time until you will change this. When you use the auto scale, you set the maximum number of request units, and only 10% of this request units will be used for all the time. Only on the peaks you will get the max number of request units. Maybe we need more explanation. For example, you have 10,000 request units, yeah, and in auto scale mode you always have provision, in this case 1,000 request units. If you have some load on your application and you do more requests on the database, uh, Cosmos will automatically scale your throughput up to this max number of the request units you set. I think that next question I going to get, it's how we can understand how many request units we need. And simplest solution, and really only one that works, it's explain the queries. For this is the example of the simple query you have in the Cosmos, and you can run get last request statistics, which give you the information about the request. When we run some this kind of query, we expected to get something like this. That's this look very fine. Request shards is close to 5, and we know that's find command name, and request duration milliseconds, it's close to 25 milliseconds. Looks very fast, but it may looks like this. Yeah, it may cost us up to 1,000 request units, and this is huge amount. Take care of your indexes. Maybe take care of the data you put in the Cosmos, because all these things that I talk at the first slide reflect the cost of the operation. Also, there is a trick with the rate limiting in Cosmos. It's a bit different that other databases. When you exceeded number of the request units you have, you can get the error like this. And your application must be ready for this, and have some logic to retry this. Cosmos does not support retrying at the database side, and you can simply if you exceed number of request units, it simply throw this error, and you have to take care at your application about the retrying. Also, as I said before, Cosmos support out-of-the-box partitioning. It support logical partition and physical partition, and only one way how you can control this is choose the right partition key. Take care of the partition key, because it's important and it can reflect your application and your cost of the operation. Also, there is very easy way to manage the replications. You can simply go the simplest way, for me at least. It's a go to the UI and click what you need. If you want to have a replica in the Australia or in India, you can simply click on this place and you will have new replica. If you want to enable multi-region rights, that's simple. Add the region and you have a new replica. Also, Cosmos support different number of consistency. There is 5 levels of consistency, from strong to eventual, and you can choose any you want. Take care. If you use the strong consistency, it may cost you 2 times more than eventual consistency. It means that strong consistency will have less availability, higher latency, and less throughput if we compare to eventual. Also, everything that you want, everything that you want about when we are talking about metrics. Yeah, we want not only run the database, we want to measure how it works. We want to always have a metrics to understand where we are and what we can improve. All these things logs and insights give us. If you want to understand how much you do a total request, or how many total requests you have, does the partition is hot or cold. If you want to go with the slow query log, you have to go to the inside page. There is answer to everything that you need. Also, if you want the slow query log, please take care of this. It works from time to time. Sometimes it's fine, but sometimes it shows very strange results. And please take care of this. Also, I think that Microsoft team will fix this soon. What about pricing? Also take care about pricing. Too many works, take care. I think that the most reasonable way how I can explain why you have to take care about this, it's you pay per hour, and the best example is auto scaling. When you use auto scaling, you pay 50% more than when you use fixed capacity. And what may cause the more problems, like when you pay more and more, when you, for example, you have a lot for every hour for 15 seconds, yes, and you have to support this. You choose the auto scaling mode and thought that, okay, I will pay for this 15 seconds in this hour, and it's very convenient to me. But what happens when you have even a lot for 15 seconds? You will pay anyway for hour, and if you have each hour this spikes even for 1:15, doesn't matter. If you have a spike, you will pay for whole hour, even database doesn't work. So take care of this, and remember, you pay per hour, not per second or other things, not per instance. Also, I have some experience with the MongoDB, and thought it would be good to compare this both solution. We know that Azure provides a highly available database with and support everything, but there is also MongoDB and Atlas team that support Mongo, and it can provide out of the box Mongo solution for each cloud. And if you want to know more about this, you can go under this link, and there is more explanation about this. But I will go with my testing. I will actually I wrote the code and decided to test this. I created two clusters with the Mongo and CosmosDB, and with different resources and different prices. Yes, for MongoDB, it costs $75 to create fully managed by Atlas team cluster with close to 2 GB RAM, 10 GB storage, and half of the CPU. And it costs close to $600 to create in Azure resources with 10,000 request units. If you want to check the code, you can go under this GitHub link and go to my repository. But I will go to the result. I decided to check simple queries that we usually run, and I decided to start with the insert. I think, okay, we have in total 100,000 documents, and let different number of users insert this document into the database. I think that one user can, at this point, can insert 25 documents in batch at the same time. And what the result I got? Okay, MongoDB, in general, it get the result close to 15 minutes. But for Cosmos, it takes close to 2 minutes, and and I think, okay, maybe we need to change number of documents in a batch. Maybe it will be more sufficient to have 100 documents in a batch. And I run the same query, and no change for Mongo. Actually, no change for Cosmos when we are talking about 25 and 50 users, but it reflect Cosmos when we have more users than 50. When we have 100 or 200, it takes longer, and that's the result. Also, I think we can try the transactional insert, and I run the same test, but insert was in the transaction, and you can see there's no big difference. We have the same result that we have with the simple insert, and maybe this database is very nice to don't even care that they have transactions. Next step was finding by ID. I also have total 100,000 documents and give different number of user, find by ID for one document at the same time. And you can see that at this point, Cosmos even better than Mongo. Not for 2 minutes, but 10 seconds or close to this, it's faster. And this is very cool. And next thing that I wanted to measure is the aggregation. I go to the MongoDB documentation and take first aggregation query. It looks like we have a group by status and then sum by a total. And at this diagram, we can see that Mongo have done this. To be honest, I got a lot of emails from Atlas that I'm doing something wrong because at this point I had more than more or less 2 million documents. It's not too much for these databases, but still it's enough to get email from the Atlas team that I'm doing something wrong with Mongo. And then I run this command with the Cosmos, and it takes, to be honest, it fails when I after 10 or 15 documents, but it takes close to the whole my life. And I just decided to move these diagrams to the Cosmos because it's only one way how I can show you the difference in the aggregation, but maybe it's only about this aggregation. Yeah, it's not reflect all the cases. It's just a simple thing that I've done, and you can check the code at the repository to compare this to databases. And you have to understand that this two databases suit different needs, and you can scale or replicate or use this in different way, and you can choose what you need, and that's it. Thank you.
Thank you, Yuri. It was really amazing speech. And it looks like we have only one question for now from our community member. Which version of Mongo API is supported by Cosmos now?
It supports 4.0. I think that 1 month ago there was a release for 4.0. Before it supported 3.6. Now it's 4.
Okay, I guess most interesting question will be: can we compare Cosmos, Mongo, and something like Redis? What
Redis?
Yeah. Let's compare with CouchDB. It will more closer to Mongo, I guess. What do you think in performance and cost? What you would recommend for our guests
I,
and our community?
I think that each database suits the some requirements, yeah. And of course, that I run the test for a Mongo and for a Cosmos, and there is different result, but it meets some requirements that I created a test. Yes, it do simple insert and simple find, but there is a lot of other things that can be handled by these databases, and at some points one is a better and one is like have some advantages and disadvantages. Also, if we are going to talk about the Redis, it's also cover different requirements than these databases, and you have to use you just have to choose the right one to meet your requirements and use it at your application.
Okay, thank you. And probably one more question from my side. On your slide, cost for CosmosDB was really huge. Something about $600 comparison with $60 against MongoDB. Do you have any understanding why it's so huge? I mean, it's something unbelievable for small project.
Yeah, it's really huge. I don't have to say anything about this. I just choose the number of request units that can be comparable with the Mongo, and that's the result that I have. I can explain why this huge. Maybe because Azure thinks that it's good price. I I can say.
Okay. Uh, Again, from top of my head question, what about availability? Can we compare Mongo Atlas solution and Cosmos DB from Azure?
Yeah, they provide us the same close to the same availability, and in this link that I put at the start of the comparison, there is more things that we can compare with Mongo and Cosmos. Mongo from Atlas team, and there is close to the same availability as Cosmos DB with the Azure.
Okay, thank you so much. And we are going to have a 5 minutes break and we will switch to another speaker. Thank you, Yurii. Woo.
Thank you. Bye.
Bye. Hello again, guys, and let me introduce our second speaker today. It's Bogdan. He's lead software engineer from EPAM company, and he's going to talk a little bit about REST APIs, Swagger stuff, and yeah, please meet Bogdan.
Yeah, hi everyone.
Hello.
Super excited to be there. Didn't spoke so much, so yeah.
Could you please tell us a little bit about your experience with Golang and with REST API?
Not so much, honestly. I started to road to my first program on a Golang was yesterday written, and well, I never heard about Swagger anymore. Obviously, I'm joking right now. Yeah, so I'm kind of started working with Go about. Honestly, I even don't remember it. It was kind of like um 5, 6, 7 years ago, somewhere like this. I heard about this language. I tried a few Hello Worlds, but yeah, really production one. I do remember my production code was shipped on a Go, like I would say 3 years ago, somewhere like this.
Okay, and are you going to talk about the real case of Swagger usage, or it's
Yeah,
just
yeah. Yeah. This is a real case which we deal with on a project, honestly. So yeah. There were a few challenges, and I want to share how we solve at least partially them.
I heard a lot about Swagger and REST
Hmm.
APIs, and I heard that people say, "Oh, Swagger can help you to automate all of that," but you know, when I tried to automate something using Python and Flask and Swagger, I had to write huge annotations.
Oh
And
right, yes, yeah, yeah,
is this
definitely.
still situation with Go, right?
It depends. It depends. Well, basically, it's everything about your requirements, obviously, right? So Um, usually those annotations which you mean, right? So this is probably in the cases when you have an old project, probably it's some legacy project, or is it just a project which you wanted to improve and add the Swagger documentation, and obviously it would be much easier to you just to annotate the pieces of the code because actually because there is probably if there is no documentation and you wanted to create some kind of documentation, right? So you're going now from a code to the documentation. So well, this is I think the use cases also for annotations as well. um, but generally speaking, I would prefer that first of all we create the Swagger, basically agree on API and then do a something, right? So you first are thinking about something, right, and then doing them rather than doing and then thinking, right? Well, I at least at least people trying, right?
Yeah, I wish you lucky, and let's start.
Oh yeah, sure. Yeah, I have to share my screen, right? I hope I will share it correctly, at least. So I hope you see my screen right now, and I will hit the play button and right. Okay, I hope you see my screen. Okay, so yeah, we will talk about how to automate your Swagger. Yeah, and as you mentioned, my name is Bogdan, right? I'm software engineer at EPAM. So yeah, first of all, just briefly, what is a Swagger, right? So just to make sure that everyone is aligned. So actually, Swagger is just a plain simple YAML file, right? So it's a YAML file which describes your RESTful API, basically defines a behavior of your API. Well, usually it's RESTful, right? I put the link to the specification because obviously you have to deal with some specification in order to do description of your service. And also, Swagger is not only about the YAML file, right? So this is also the set of open source tools which helps you to build, design, and basically document the RESTful APIs for you using those YAML files which we already mentioned. So The most common one, maybe you ever heard, is Swagger UI. It's pretty standard one. Okay, so basically this is a photo of Swagger. So I used the just plain simple example file, example Swagger from Swagger documentation. It's a pet store API, so you might see this. This is just a simple Swagger file which defines shows the information, defines the host, tags, schemes, and as well as passes, where you defining your routes and methods which you will expose, and and explicitly you're saying about the types which you're expecting from to being passed by a body or passed wherever, and the types which you're also returning with your APIs, right? Okay, so why we need actually Swagger? Well, first of all, we need a standard, right? In order to do some kind of API design, we need a standard. Second one, it's a text. It's YAML. It's a text, so it's a human readable, right? When we are defining API, people usually using, well, not obviously the people, machines will use them, but people tend to implement those or integrate with those APIs. So usually people reading those documentation. So it's a human readable, first of all. Well, because this is a YAML, it's also easily could be parsed by machine. So this, I could say that this is also machine readable. It's super easy to adjust, and because this is a text, you can easily review it. So this could be, the Swagger could be a part of your code review. And basically when you do some kind of architecture review, or when you're actually doing some service refactoring or changes of API, you're explicitly showing as a your diff in your source control that you're making the changes to API. And as well, it's widely adopted via communities. And because of that, there is a wide variety of tools which are built on top of Swagger. You can go to this link and see by yourself. It's pretty huge, and probably, well, most of the languages are supporting it. Okay, so what's the problem? And what the problem is not about that Swagger, is actually what challenge we actually faced on our previous projects. So imagine that you have a company where you're dealing, you're dealing with microservices. You have at least 4 teams. It's bigger, and you have at least 30 services, right? So different teams have an ownership of different services, and some of them services integrates by yourself. And well, internally we have a lot of consumers as well. So people tend to build their RESTful APIs differently, which is fine, right? So you can have a variety of services. But this brings us to the problem. The problem is that we have inconsistency in APIs. So basically, each team or each even team member which have an ownership of some particular set of services have their own understanding of how the RESTful would be. Well, because this is probably because our RESTful is so big. Well, it's so big standards that a variety of pieces of this standard can be treated by differently. So as well, that documentation is not well maintained. I'm not saying about the initial. So when people writing a service, right? So we firstly defining an API for the service, but with the time being, when people making feature changes or adding features or doing some kind of refactoring etc, people tend to update the service but not update the documentation. So usually we had such also a challenge that instead of doing the check of a Swagger file, people usually go to this particular team member who have an ownership of a service, and check with them which parameters you have to pass there, or actually something doesn't work. So please tell me which parameters you have. And obviously, there is no consistent place with the documentation. Some team members store it in a knowledge base. servers, and some of them just place it in a README file. Okay, so let's let's try to fix this one. So obviously, what we can think of and why actually we are talking about this. So this is a Swagger, right? So we can define your APIs using Swagger, and that's all, right? So you're basically moving everything from KB and the README to the Swagger file, and you're defining a Swagger. Well, honestly, it works, but people forget to update the Swagger as well, because this is just a same document as it was previously. So in the end, you have something like this. So we have a Swagger API. So you basically build a Swagger API file, and your API is not relatively same that actual API is not relatively same as a Swagger API. So we thought about this as well, and instead of, well, as I mentioned, instead of having the consistency, we just move all of our KBs to the Swagger files. So we really understand here that we have to somehow automate the stuff, right? So we need to understand that Swagger should be our, Swagger APIs or definition files should be our source of truth, and we understand that building handlers, ATC, should be on a second place. First of all, you're defining a Swagger, you're making changes to the Swagger, and then it should be automatically propagated to our code. Okay, so we start doing a research. Obviously, because we're using Go, everything everywhere is a Go. So okay, sorry, mostly everywhere is Go, not always. We are looking for generators. So first what we thought about is a native. Basically what Swagger provides, it's a Swagger codegen. It's basically the generator for server stubs or clients, is the case. It's written in Java. It provides fairly usable code, but it's written in Java. I'm not saying that Java is something which is something bad, right? I'm saying that this is another dependency which we need to stick to, and we don't have a Java services at all. So next one, we look at the Goa. We also tend to think about, like, we provide the gRPC services and provide them through the gRPC gateways. We thought about the Go Swagger or Swagger 2. So in the end, we stick with the Go Swagger. Why so? Well, first of all, because of the stars. Honestly, this project had the most stars on the GitHub, so it's more than 6K stars. Wow, great. Second of all, it was written in Go in mind, and the code generated by a Go Swagger basically was the best code. This suitable, I would say, and formally better than other generators was doing there. Okay, so let me show you something regarding those demo. Let me just demo it. So firstly, I will stop the sharing and start it once again. Let me share my screen once again. Yes, I want to share it once again. Okay. All right, there is a bug in macOS there. Okay, so I hope you see my screen right now. I will try to enlarge them. Okay, so we have a demo. So you might see that we have a pet store YAML file. So as I mentioned, I can open this with line text. And you might see this is a pet store API, which I showed you recently. So this is a list of, basically this is a pretty huge API right here. So You can see it's around 700 lines of code. So we are defining our models here: a pet model, tag model, API response model, user model, category model, etc. So I would not go through everything here. I just wanted to familiarize you. Okay. So let's create a folder. We'll call it Swagger, and let's copy this Pester API to the Swagger folder. Okay, so basically, imagine that this is our service. We're starting from a single YAML file. Then let's do the Go modules initialization. I'll call it Swagger demo. Okay, so our Go mod initialized right here. Cool. So I already pre-installed the Swagger utility. So I believe it has a help function right here. Yeah. So I already pre-installed the Swagger utility, and you may see it's right here. So it have a command called generate. Generate what? A server. And it wanted to have a pointer to a file. Okay, we're having something there. Okay, it's generating. You see all those messy output. Honestly, I never checking this one. I just always checking only this guy. Okay, I doing the go get. Why I'm doing the go get? Because I have a because I need to grab all the dependencies which it internally uses. So internally it uses Go Open API as well as some other GoNet dependencies as well as MongoDB. Honestly, I'm familiar why exactly I think this is some utility functions. Okay, so we have our Swagger folder, and you might see we have right here out of the box. We have three folders right here. So let's go from bottom to top. So this is a REST API. This is basically where we defining our server. We defining different operations on our entities, on our models, which is pair, store, and user. So for example, if we go to user, we see that there is a create user, for example, and this is a create user handler function, which basically defining a type for this one, and we're describing how it will work with our HTTP server. Next one is a models. So models is relatively simple. It's just, for example, an order. You might see this is it's a complete, have identifier, pet ID, etc. You might see this is this is just a plain old structure. As well, it provides all you also for you validations. So it automatically generates for you validations. As you might see right here, it validates the status and shipping date, etc. Because of that, it uses some custom, well, not custom, but well, it uses those libraries for this. Okay, next one is CMD. CMD is also relatively simple. It's just main.go. So it automatically generates for you an entry point right here. Yeah, this is pretty much all as for Swagger. So if we, well, at least let's start this one. So if we consider to start it, I do know that it accepts environment variable, so I will tell port 8080, right? And then I will do go run cmd, cmd swagger main.go. Well, finger crossed, I hope it will run. Obviously, it's a demo, it shouldn't run from first. Okay, it's running, wow. Okay, so let's try to crawl it. So it would be a local host 8080. Honestly, I forgot the road, so I have to check with my Swagger. Well, great, I have a Swagger. Okay, so base pass v2. What else? Base pass v2. Okay, so let's give it something by ID. Honestly, okay, by get order by ID. Oh, great, order by ID. So we have an order get order by ID. One more slash. Get order by ID, obviously one. Okay, and you might see it's not implemented. So by default, Swagger does not implement the functionality for you. So you might see right here that it's not implemented, and we will go further there. As well as Swagger also provides to you the authentication logic. So you might see that we are also describing the security. We're saying exactly what is our security requirements right here. And for example, let's give us a try with another endpoint, which has a get. So find by status, right? So it's find by text is deprecated. Okay, great. Pet by ID. Pet by ID. All right. So we will go and grab some pet by ID. So you might see that by default, I'm getting 401, even though I didn't implement the authentication logic. It's defined explicitly that it expects API key. Even if I provide an API key, some custom API key, wherever, it will then crash again with a 501. All right. So I think that's all, and we can go ahead with next presentation. Okay, I hope you see my screen. All right, so what we did, and actually I forgot about doing a part of it, but yeah, it's we generate a file, we generate a server. We can generate, and I will show you later on how to generate a client, and we also can generate a markdown as well with it. I will do this in the next demo. But you're probably questioning, right? So where I put my code, right? So where should I place some? Where should I put my business logic? And this is pretty common question, right? So and this is now your decision, right? So you have no code ownership here, and you actually designing where to put your code. So generally speaking, I putting it in. I creating a separate package called an app, and I putting it just on a root at the root of our service, and all the business logic are there. All right. So now one more demo. I will show how I am gluing this one. Again, I will stop sharing the screen and go one more time. Now we will show you. All right. Okay. As I showed you already, I generated a service, right? Again, I can generate you as well a client. Which it's relatively simple. It's also accepts the file for a PetStore API and generates a client. It's doing some magic, and voila, that's it. We generated the client. So if you go here, you might see the client. So why we need a client? So usually it depends, but if you're building some kind of shared services which will be consumed by other infrastructures, you might create this example client, so the consumer of the application can use your Go client. So usually we're just placing it also in a source. So if somebody wants this client, they just go get this client. It has a separate package client, and it's basically consumes as well the modules, and it uses a standard HTTP client right here. So yeah, this is basically basic client. Next one is how to generate the markdown. Honestly, I'm relatively really, I believe so. You generating these markdowns, but still, I do believe there was some teams which generate the markdowns as well. Don't forget it's markdown, PetStore, YAML. Okay, yeah, so it will be this. Okay, so it's a generated a markdown. So if I go code dot, okay, Visual Studio, I believe in you. Yeah. you might see it's generated the Markdown file as well. Well, it depends. So what you're expecting, but this is a relatively simple Markdown file. It describes you by a tags, well, basically by a model's the endpoint. So and explaining it shows the types, which is and basic validation which will apply there. Okay, going back to our example. So as I already showed you, you have a Swagger, right? And you wanted to create you want to use an app. Well, you want to somewhere place a business logic right here. So I already created this one just in order to save our time for typing. It's the same Swagger app, but I just create an app folder right here. So you can define your own, for example, abstract, which will consume the pet store API, which is basically a set of handlers, and it will override all the handlers by your own implementation. Obviously, this should not. This could be done in a. This could be decomposed, or could be done only in this file. It depends on your needs. Then, what about the generated file? Where actually we are gluing this together, generated files and your APIs, and your implementation. So this is a config Swagger file. So you might see the comment right there. This is a safe to edit, because once it's created, it will never be overwritten by a generator. So each time you rerun generator, those changes right here would be saved. It's basically the configuration which invokes right before your server starts. So you might see this is configures serialization or consumers producers. It's also, you might see it also configures the API key validation, basic authentication, and this is our part which I added right here. So it basically I passing it API. Our API, and it would be here in this function, it would be overwritten. Okay, so just remind me what I did right here. So store get order by ID handler. Okay, so basically what I did right here, I use generated model, which is store model. It basically defines for you, depending on how you define it in the Swagger, what is the output of this one. So just give me a second, I will show you right here. So just to be clear here, so you might see that we are defining exactly what would be the output right here. So based on this defining responses right here, you will have you will have a different set of responses already generated for you as well. So I do believe it's somewhere somewhere right there in operations, store, and this is get by ID responses. And in the get by ID responses, you might see that depending on what we have in the YAML, we are have this response. This is a OK response. It has a pretty good fluent API, so it basically provides you ability to chain your configuration of responses. You might see that you're creating the response, and then you're filling it with a payload as well. Okay, let's try to run it. Actually, I will go to Swagger app. Okay, let me clear here. So again, port 8080, Swagger pet store server main.go. Yes, I think so. Okay, it's running. Okay, so it's binding to port 8080. So then, remember a while ago we have a 501. So it's a get order, right? It's a get order by ID handler. So this is it. So I'm asking for a 1, and it sends me OK, and it sends me a response. Oh, okay. So yeah, by default it sends it in a application XML. Just a second. I have to change the header, so it should be accept. I hope I spelled correctly. Application JSON. Okay, yeah, you see, we have our JSON. So so this is it, right? So we generated a response with a payload which is ID 3. We didn't fill up everything else, so we are taking the default values of the structs as well. Okay, so and basically right here you can have your own in app folder. You can have your management of databases, etc. repositories, etc. Okay, and now I can go back to my presentation. All right, so drawbacks. Obviously, everything have a drawbacks, right? So first of all, and this is the most common drawback which everyone are struggling when they doing working with a GoSwagger. This is the lack of support of Open API v3. So right now it's implements only v2 of API. What brings us Open API v3? So first of all, there is lots of new standards. There is lots of new validations, etc. So much more functionality right there. And this is not actually the Swagger API now. Now it's Open API. So this is a standard de facto, which is open standard. Next one is the models itself. When you're adding the validations there, the models itself using pointers. So you might see a lot of models which have had the fields full of pointers. This is because well, because of the validation, how validation works. Basically, the field is required, so how you define if this is a required field or not. So it's rather there or not, and this is they checking basically this with nil values or not. Next one is well, limitations in validation on a v2 spec. And of course, the custom types, right? So in order to support some parts of validation, you will have to use some tricky datetime objects, which are in a str standard FMT package. So yeah, all of these things is a drawbacks, and I feel we can live it. Well, at least in our projects, we can live with it, and benefits which the GoSwagger brings to us is much bigger than the drawbacks which we have. Right, but this is fair enough, and we should keep in mind this. Okay, so summary. GoSwagger is a brilliant tool which help us a lot. Now, basically, we using this GoSwagger tool, we finally have a design first approach, API first approach. So basically, before actually doing something, we are making changes to the Swagger file and regenerating a code from there, a code from a GoSwagger, using GoSwagger. Sorry. So now we know for sure that when you open the repository and look at the Swagger definition, you're pretty sure that at least from a parameter standpoint, not a business logic obviously, but from parameter standpoint and what we are accepting and responding to, you basically have a different. You're pretty sure what to expect. And yeah, there is a few limitations right here, but we are dealing with it. And yeah, thank you everyone, and I'm open for your questions.
Hello, and thank you, Bogdan.
You're welcome.
We have a question.
Really?
Yeah, one more. Have you any idea how to migrate from Swagger to version 2 to version 3?
How to migrate Swagger from version 2 to version 3?
Yeah.
Well,
is this difficult?
So this is the thing which I mentioned right here, right? So the limitation. So Go Swagger tool, it's exactly are not right now not supporting this one. Still, there is an initiative to use there is an initiative. I would say it's a Go Open API library, which which basically start work on the implementation for supporting Open API v3. Despite this fact, I would in case if this is really necessary, I would rather check the Go Open API if it's suitable. If not, I would expect to use a Swagger CodeGen. I do remember. I think it supports. Yes, it supports 3.0. So the code itself would not be the I would say Go like what we understand by idiomatic Go way, but still it would be usable. So Swagger CodeGen it would be your option right there.
Okay. Why you prefer Swagger against Postman?
I'm not saying that both of them can work, right? So it for us so Swagger for us is the documentation. We are truly working with truly using Swagger only for keeping our documentation of RESTful APIs updated. So, and basically with generating of the handlers, we enforcing this. But Postman works Postman works as expected. So I do remember. I'm not sure honestly, but I do think you can import to the well. Basically, Postman are familiar with the Swagger, and you can use Postman with the Swagger, right? I mean, you can import a Swagger definition to Postman and do all the calls through the Postman.
You can do that.
Cool.
Let's switch to another question.
Cool. Yep.
So Go Swagger is still in development, and something could be broken in minor updates. So, do you think is it safe to use it in production?
We are using it.
Are you crazy?
No. So you mean Go Swagger, right?
Right.
Yeah. So no, it's totally fine right here. Well, again, everything is about it's about whether it meets your requirements or not. Yes, we understanding that this is an enthusiastic project, I would say, so that, and we are using it. We are using it on our production as well. But yeah, we doing a couple of testing. We had a few challenges that minor version actually broke some stuff. There was a case, but while maintaining this one and good API testing, and well, basically helps us a lot there. And basically by broken, I mean that code was not compiling. So it generated a piece of code, but it's not compiling.
Okay, but what about security aspect?
Great question. Security.
It's not my question.
Excuse me?
It's not my question.
Fine. What about security of what exactly? Overall security?
I mean, Go Swagger is still in development, and you bring a lot of code generation inside your project, like server client. How you can control security aspects of that generated code?
We do it. So each service where we going to production, we are doing a lot of review. I mean that not code review, which you're thinking of, like your daily, what you're doing on a daily basis. This is a review, a security review, so by experts So they doing their own, and they never sharing honestly with us the code checks, code reviews, and we usually, well, all the new versions of our services are going with this path. So we the company which doing the code, which doing this security review, I honestly I don't remember the name of the company, but yeah, it's we consider this as a question. Well, and we pass the security. Oh, yeah, security audit. But yeah, yeah. Until we are passing the security audits and IT, well, and because we are sharing actual implementation with them, and they saying that code looks great, and well, and they doing some automated security checks there, and until they saying that this is great, so yeah, we're fine with this.
Okay, Alexei, I hope you have answered your question.
Yeah.
Question from my side.
Great.
You generated so many code. How you can be sure about performance?
Great question. Yes. Yes. Great. Thank you. Indeed. When we are talking about the performance itself, so I could not share with you exact numbers because obviously I don't remember it. I just remembering a relative relative information there. So we did a performance checks as well, and in comparison to the popular frameworks itself, it's it's around, I believe, 5-10% slower than, for example, I do remember they had the option to, for an echo, and with other framework, honestly, I don't remember. I didn't do this, but I do remember. So the performance is a little bit, well, I will not say bad, but I'm. Yeah, there is a performance. It's also not a limitation, but drawback as well. That I believe about 10% performance gap there. As for generated the code, yes, this is a good and a bad as well. So the generated code on the initial commit, when you actually generate the code, yes, you're dealing with a large set of files. But actually, when you doing some changes to your API and regenerating your code, and because the code is also a text, right? And when you see the diff on your screen, this is actually helps a lot, because it's not only showing you the changes in API in a Swagger itself, it also shows you how the code would behave in a different way as well. So it's also kind of a part of validation of what is generated by code Swagger.
Yeah, my question was like, I need better understanding where is overhead, because if tool should improve something like your manual stuff, then you will get overhead. Performance, it's probably one of aspects. Security, we still don't have right understanding how often we have to run security checks and potential issues from another side.
So from a security perspective, like basically, if you're using, well, Swagger does not it provides, but obviously you don't want to use authentication keys, etc. So it also provides to you a standard bearer token authentication right there, and the implementation side of validating the token, and when saying that yes or no to the resources, I mean the authorization part is defined by you. It's basically your piece of code. What Swagger gives to you is basically some kind of middleware, which provides you a platform where you're actually writing your code. But from implementation standpoint, there well, mostly you're defining mostly you're defining a security there. Yeah, and honestly, I think I forgot your question. Can you repeat the please again?
I'm asking about overhead, which Swagger brings inside the project.
Overhead.
Okay, we define that performance a little bit slow.
Yeah, it's a
You have mess of files. It's okay, probably. Anything else?
okay. Okay. So yes, refactoring. If you're doing some pretty large refactoring, or maybe, well, obviously if you're in production, it should be quite generous one, but yeah, refactoring also, well, the code review of some bigger refactoring also brings you a lot of diffs there, right? So basically it's not only your business logic, right? It's also a lot of changes on the handler side. And if your PR, well, which basically makes your pull requests much bigger. What I'm saying that it's not only your business logic; it's also a large set of files which is generated by a Swagger. But it's also like I would say I would say this is not a bug, it's more likely the feature, because this is probably the same as with vendoring. You know, when we update something, you vendor it exactly in a folder called vendor, you usually people also checking what's you vendoring there. Yeah.
Does it mean that you are committing generated code inside version control systems?
Yes, we committing it. Yes, we committing it. Just in order to make sure that, so first of all, we're committing a client, right? Because somebody wanted you some of other services, like for example, well, we have I forgot the name. It's second party services. I mean that we're writing some internal services to other services inside of our organization. So they, if they using a Golang, it's also they can use our generated client as well. So, and obviously it brings a lot of flexibility for them, because it's you're using already code there. And yeah, and answering to your question, yes, we're committing the generated server code.
Okay, thank you. Looks like we have no more questions. Thank you so much for this detailed explanation. And
Yeah, no problem.
looks like Swagger a great way to keep your services documented. Code,
Yeah, I
code,
hope so.
code generation from Golang perspective for me it's something like it's a tricky question.
Yeah, obviously. So obviously, every time you are talking about generation ATC, so this is based on your requirements and what you're expecting from your service to do, and what you basically with what you're fighting there. So our fight was that we read internal services for our internal use cases, right? So, and the documentation was a crucial thing there. So we know for sure that our all our internal services are know how to communicate with us. So yeah.
Let's stop that our boring discussion. Just summarize. What kind of things that approach helps you to solve on your project? Did you speed up your
in one sentence? In one sentence, or I can explain.
In one sentence. Let's
Yeah.
say 2 sentences.
2 sentences. Okay. So our Swagger file and actual API is equal. So you know for sure that Swagger is a source of truth. That's all.
Okay. Sounds like solution, really. Thank you so much. Yeah,
Thank you.
that's it from our side today, guys. I hope we will back online soon. It really depends on Bogdan. He's organizer of that stream today, and he's a little bit shy to to present you presentation and like start of our session today.
Okay. Yeah, thank you everyone. Thank you for the questions, and yeah, thank you Yurii for actually Yurii is sitting right next to me, so that's why when I say thank you Yurii, I looking there somewhere. Yeah, yeah, I hope I will meet you soon. Maybe I will ask actually ask a permission. Can I share an audit, security audit of this of our code, at least like what the security team are looking there. So share some internals, but this is a future talk, I think. Okay.
Do you know what? I just recognized that Yurii was talking about Cosmos. No, Yurii and Cosmos.
Right?
Yeah, right. Thank you so much and see you soon. Bye bye.
Yeah, take care. Bye bye.